Alright, so we're doing the next week's interactive assignment, creating elephant toothpaste. I did this once already and it did not turn out quite like I thought it should, and so we're going to give it another shot. So what I have with me are just a bowl to kind of contain the foam. That was one of the things that went wrong, is I made a huge mess. But two, I've got just a small water bottle here, and so I'm going to try to keep everything right here in this frame. You can see it. My eyes might not be completely here, but we'll try. So what we're going to do is, in the water bottle, I'm going to put hydrogen peroxide, soap, and then food coloring like the video showed, and then after that I'm going to take this cup of warm water, mix it with yeast, and then we'll add the yeast into the solution we have in the water bottle. And so what we should expect to see is the bubbling out. So I'm going to start doing that, and I'm going to try to explain what the reaction is as we go. So the hydrogen peroxide that we're adding, the H2O2, that is what we're going to try to break down. So not us, but the yeast. Yeast contains an enzyme called catalase. Catalase is very good at breaking apart oxygen from hydrogen peroxide. So when that happens, there's this release of oxygen. So if you were to pour hydrogen peroxide on a cut at home, then the reaction would likely be that you would see some bubbling even from our skin. I'm adding soap now, and this is going to be kind of, I guess, a container, so to speak, of that oxygen. So the reason we see foam in elephant toothpaste is because the oxygen is being captured by the soap and kept into those bubbles. And so when we see the foam coming out so quickly, because the enzyme catalase is causing the reaction to form so quickly, it's actually the soap containing all of that oxygen that just expands and expands until the limiting reactant runs out and the reaction's done. So I'm going to go ahead and put yeast in some warm water. This is heat, if not too hot, will increase the reaction of the yeast. If it's too hot, it'll kill it. So we don't want to use super hot water when we do this, just some warm water. Then I'm going to take a spoon and stir this up a little bit. I'm going to take this down. You can see I've got red food coloring in here. Mix this up a little bit more. So as mentioned in the note for the assignment, this reaction is going to be exothermic, meaning that it's going to lose heat. And you can tell that by the temperature of the bottle. So we're pouring the yeast in. Okay, I'm going to let that go, and so it's overflowing. We're seeing that conversion into oxygen, but it's not going to be near the intensity of what was in those videos that we watched, because I only used a 3% solution of hydrogen peroxide. If we were to take, it is really showing up though. See it almost getting that Pepto-Bismol color. So anyway, as I was saying, when we increase the solution percent of hydrogen peroxide, you froze up on me. I'm just going to finish talking this one out, I guess. When we increase the amount of hydrogen peroxide, or the percentage of it within the solution, the result is going to be a more intense reaction. So like in the videos we watched, you would be able to see the yeast as it catalyzes and speeds up the breakdown of hydrogen peroxide. It would almost have an explosive tendency because of the intensity of the reaction and the pressure within the container. So for whatever reason, I don't know why, my computer froze up on you, so you're not going to be able to see what I'm looking at. That yellow bowl is about halfway full, and the bottle is still working to break down the hydrogen peroxide, and the soap is bubbling up to contain those oxygen molecules so that they're not able to escape into the atmosphere. So that's all I have on this one. Again, sorry, I'm not sure why the computer keeps freezing up on me, but you were able to see the experiment. So I will check in with you next week. Thank you.